Let's run through the question. So we've got a sequence 2, 9, 16, 23, 30. The first thing we're asked to do is to show its arithmetic. So if we're showing something's arithmetic, we're showing that there is a consistent common difference between the terms. So we can do that through subtraction. So we'll say 9 take away 2, well, that's 7. And 16 take away 9, also 7. And 23 take away 16. And 30 take away 23. They're all 7. So we'll say, hence, arithmetic. Part B. Find the formula for the general term un. So as we know already, we've got a way of doing this. We know that un is equal to u1 plus n minus 1d. And because we've got this sequence in front of us, we can already see u1 is 2, the first term, and that difference is 7. So let's just plug those in, and we're going to have our answer. Un will be 2 plus n minus 1 times 7. Now, we should probably simplify that a little bit. So let's expand the bracket, 7n minus 7. So I think probably the best way of writing this would be negative 5 plus 7n. That is our formula. That will help us to find any term in this sequence that we like. C, let's do it. So part C, find the 100th term of the sequence. Okay, so we want to say, well, n is 100. So u100 is going to be minus 5 times, plus 7 multiplied by 100. This will be 695. Okay. Part D. So is 828 a term in the sequence? Well, let's find out. Let's go backwards, right? We want 828 to be some un, which we've got to discover perhaps. So we'll say, this is part D, 828 is equal to minus 5 plus 7n. Right, okay, so if we know that, let's just start solving this equation. So we'll add 5 to both sides. 833 is equal to 7. And if we divide through by 7, we're going to have that n is 119. So yes, this is a number in the list. It is the 119th term in the list. Okay, so we've proved that it is. Let's take a look at part 2. Is 2, 3, 4, 1 a number in the list? Well, again, we'll set it to minus 5 plus 7n. That general formula we found. And if we add 5 to both sides, we're going to have 2, 3, 4, 6 is equal to 7n. Now, we're going to divide by 7 again now. But what we need to look out for is if we don't get a whole number, well, what is that going to tell us about n? So if we divide through by 7, we're going to get n is equal to 335.14. Well, we don't have a 335.14th term. This is a whole number problem, right? Okay, so we're going to reject that and we'll say, no, it's not in the list. Let's carry on and take a look at another example. We're going to progress these examples and make that difficulty level a little bit more challenging every time. Okay, so find k given that 3k plus 1, k and minus 3 are consecutive terms of an arithmetic sequence. Well, if they're arithmetic, the difference between the terms is going to be consistent, right? It's going to be d. So we could certainly say that d is k minus 3k plus 1. And we could also say that d is minus 3 minus k. So if we've got two competing values for d, well, we can say they're equal to one another. So what we can say is that k minus 3k plus 1 must be equal to minus 3 minus k if this is an arithmetic sequence. Let's just simplify and solve. So we'll just get rid of those brackets very quickly and collect up some terms. We'll have minus 2k minus 1 on the left equals minus 3 minus k on the right. If we add 2k to both sides and we add 3 to both sides, we'll end up, there we are, look, k is equal to 2. Not too difficult at all. What about a couple more examples? Let's take a look at this one. Find the general term, un, for an arithmetic sequence with u3 equals 8 and u8 equals minus 17. So we're going to need, just like before, a u1 and a d, because our general term formula is un equals u1 plus n minus 1d. And we can't input that u1 and d until we found what they are. So let's start off with some statements. Let's try and get what we do know into expressions that involve u1 and d. So we've got when n is 3, right? The third term is 8. So what we can say, well, if n is 3, u1 plus 2d is 8. That's how we can write that third term. And when n is 8, we also know it's minus 17. So u1 plus 7d is going to be minus 17. And don't forget where the 2 and the 7 come from. It's always n minus 1. It's 1 less than n. That's the number of d's we have. Okay, so here what we've got really, in essence, is two simultaneous equations, right? These two here, look. So what we can do is we can try and collect them up. I think I will do this by multiplying this one by minus 1. So let's keep the top one exactly as it was. And we will rewrite the lower one multiplied both sides by minus 1. And now what we'll do, we'll add them up. So the u1s will cancel out. We'll have negative 5d is equal to positive 25. So if we divide both sides by minus 5, we'll see that d is negative 5. From there, we can just go back and plug that into one of my original equations I found to find out u1, right? So if we just take maybe the top one, we can say that u1 minus 10 is going to be equal to 8. So therefore, u1 is going to be 18. Right, we've got all the information we need. Now we can write out that general formula, subbing in our value of u1 and d. un is going to be equal to 18 plus n minus 1 times minus 5. And that's probably enough. I mean, let's simplify it, I guess, make it look a bit nicer. We can expand the brackets. We'll have minus 5n and a plus 5. So we'll have 23 minus 5n as our final answer. There we are. Right, one more quick example. So insert 4 numbers between 3 and 12 so that all 6 numbers are in an arithmetic sequence. Okay, so let's just think about this a second. We've got to find 4 numbers. There we are. We know u1, let's write that down, is 3. And we know that u6, 1, 2, 3, 4, 5, 6, so u6 is 12. So if we represent that 12 as the u1 plus 5d, or in other words, 3 plus 5d, we can work out what that d is. If I take 3 from both sides and then divide through by 5, we'll end up with our d. d is going to be 1.8. So now it's a very simple case of just adding 1.8 as we go along. So if our first number is 3, our next one will be 4.8, and then 6.6, 8.4, 10.2. If we've done it right, another 1.8 will get us to 12, and of course it does, and we are finished.